I'm Miranda Fateri from University of Aalen, and I'm a team lead for this project. I'm here with my students, Sebastian Uhl and Konstantin Schuler, and also with Professor Matthias Haag. So we are printing a lunar regolith mixed with thermoplastic elastomers, and we will check the feasibility of printing the mixture right now. 3D printing, we build objects layer by layer, so we're interested to see the layer adhesions between among the layers. And this one is a water experiment box. We check the contact angle of the water with different surfaces. The 3D printing of regolith mixture with flexible plastic haven't been done and investigated yet, so I guess we are the first one who are investigating this. And the gravity has an effect on layer adhesions. In 3D printing, we build layer by layer, so how strong can the layer adhere to each other is our point of interest. Also, how porosity, maybe crack formation within the part will be different when being compared to the products that we print on Earth. So that's why we decided to test everything here and see the results and compare it to one that we have on Earth. "3D printing is almost fully automated, and you're very free in geometrical design of your geometries. So it would be very helpful for astronauts if they need something on site which is damaged to replace it, or which didn't exist and they need it there, so they cannot wait for a long time for it to be transported from Earth. So the application of this flexible material, which we are trying to print, could be for the astronauts' suits, or gloves, maybe some layers of that, or anything else in the laboratory which needs to be placed on a membrane-like material. We don't want to use that much of plastic anymore, so mixing plastic with additives could help us in order to have more sustainable products. So if it works like this into certain point, we could maybe use it on Earth, but not, I would say right now, not necessarily.